Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aisyah binti Asbullah, and today me and my friends Nur Amira Shafika binti Suhaimi will present our project, which is Atomic Absorption Spectroscopy (AAS) and Atomic Emission Spectroscopy (AES). First, we will go to the introduction.
So, we go to the introduction. What do you understand about the atomic spectroscopy? So, atomic spectroscopy is a measure of the wavelengths or intensity of light that emit or absorbed by the free atom. So, spectroscopy means the interaction between the matter and also the radiation of wavelengths. So, it consists of two, AAS and AES. So, AAS stands for Atomic Absorption Spectroscopy and AES Atomic Emission Spectroscopy. So, next. Okay, before this I explain about the atomic spectroscopy. So now I will present about the atomic absorption spectroscopy. So what is AAS? So AAS is basically the method of spectroscopy that relies on absorption of the specific frequency of light by atom or free metallic ion. So it used to detecting metal and also metal light in the samples. So this technique that use of wavelength of light specifically absorbed by the ion element. So we go to the working principle of AAS. So first, atom of different element absorb energy of wavelengths of light and make a transition to the highest electronic energy level. So the analyte concentration is determined from the amount of absorptions. So this is last part of AAS. I will present about the two types of atomizations. So first, flame, and the second is electrothermal atomization. First, flame atomization. In flame AES, the sample will aspirate into the flame using a nebulizer. So this technique is very familiar, used to detect matter in the sample by absorbing light at specific wavelength. So then the metal ion in aqueous solution are converted to the atomic state by the means of flames. So the amount of light absorbed and the analyte concentration is measured when the light of wavelength is supplied. So flame atomic absorption is very accurate quantitative technique and also good qualitative techniques. So next we go to the electrothermal atomization, or we can call as a graphite furnace. So this principle is same as a flame, but the difference is the atomization of the sample. The graphite furnace uses a small graphite tube with a strong electric current to heat up the sample. This method is more sensitive compared to flame atomizations. The comparison between two AES can analyze in sample in ppm range, but the graphite furnace can analyze the concentration in ppb range.
Okay, next is, what is Atomic Emission Spectroscopy (AES). AES is a procedure of chemical analysis that uses the light intensity emitted. In atomic emission, small part of sample is vaporized to form free atoms that reach energy, which is from lower to higher energy state. On returning back, emit a photon of radiation. AES sources consist of flame atomic emission spectrometry (flame AES), inductively coupled plasma emission spectrometry (ICP AES), inductively coupled plasma mass spectrometry (ICP-MS), and also arc or spark. For flame AES, this method uses a spray solution or gas. When the flame heat evaporates the solvent and breaks the chemical bonds of the analyte, free atoms of the material are produced. Flame AES frequently used in studying alkali metals for pharmaceutical research and analysis. For ICP AES, this source is to determine the presence of arsenic in food, metals in wine, and also study the trace elements that are bound to proteins. It is also used for analyze trace elements present in the soil. Furthermore, this method also used by expert forensic to study the soil sample found at the crime scenes and ascertain their origin. It is also used for analyze the motor oils, which is to determine the quality control and help it functional efficiency of automobile engines. For arc and spark, this method is used for analyze solid sample for metallic elements. The arc or spark is passed through the sample in high temperature to excite the atoms. Once the atom excited, it will emit the light that disperses through monochromator and detector. Next is contents. This schematic diagram shows the differences between AAS and AES. AES uses the intensity of light emitted from a plasma flame, arch or spark at a particular wavelength. AAS used in the absorption of light to measure the concentration. In other words, absorption analyzed in the presence of light, while emission analyzed in absence of light, which is the light is from flame. Next is the differences between AES and AAS. For the function, AES method use the intensity of light emitted from a flame, plasma, arch or spark at a particular wavelength to determine the quantity of an element in a sample and for metal analysis. For AAS, it is to measure concentration of gas phase, atoms and detecting metals and metalloids in the sample by using two types of atomizer, which is flame or graphite furnace. For the application AES, it is usually used in the analysis of trace elements such as salts, water, metals, biological specimen, clinical specimen, food, physical evidence such as glass and other solid. For AAS, it is usually used to determine small amount of metals such as lead and mercury used in environmental studies such as water analysis and clinical analysis like blood sample and plasma. Advantages for AES, relatively rapid technique and use a very small sample, even less than 1 mg. Use almost all elements in predictable. Non-matter can also be determined by plasma source. For AES, relatively low cost, it is easy to use and high sensitivity. Limitation for AES, it is expensive equipment, low precision and accuracy, used mainly for metals, more operating cost than absorption technique. For absorption, only solution can be analyzed, more geared towards liquid rather than solid, and also can analyze over only 62 elements in predictable. And lastly, limit types of cathode lamp, which is it is very expensive.
Based on our presentation, I can conclude that atomic spectroscopy depend on the absorption or emission of electromagnetic radiation by atom in gaseous state. So atomic absorption depends on the number of ground atom, but the atomic emission is depend on the number existing atom. So we can conclude that absorption analysis is present on light, while the emission analysis is absent of light. Thank you so much for listening our presentation. Bye.